we've spoken about the wave factor, and in a wave how to understand what is amplitude, what is a cycle of a wave. Then we understood how is the relation between frequency and time period in a wave, all these. So थोड़ा recap कर लेते हैं जो आपको की जरूरत पड़ेगा, that whenever you have a wave, इस wave के साथ जुड़े कुछ चीजें, and you check whether you understand these or not. Amplitude for a vibrating body will be said as the maximum displacement a vibrating body makes from its mean position to either extreme or either extreme of either left or right. And in a wave it will be seen crest kitna ऊंचा है, trough kitna depth है. That is known as amplitude. And amplitude in the chapter of sound is related to loudness. And you will see that loudness actually varies with square of amplitude. Loudness varies with square of amplitude. Is amplitude clear with you all? Okay. Then one more thing we studied was wavelength. A wavelength is the representation of one cycle of a vibrating body, a repetitive motion, or an oscillating body in the form of wave. Wavelength is how much distance did the wave travel as one cycle passed. So typically a wavelength is seen as one crest plus one trough denoted by the symbol lambda. Okay, and this is measured in meters because a wavelength is always a length. After this, we got to know something which is known as frequency. Frequency tells me that in 1 second, how many cycles happen. Okay, so it's represented as CPS or as second minus 1 or as hertz. All are same. How many cycles in 1 second? ठीक है, जैसे आपकी knowledge के लिए, because you are in now grade what do you call 9. So let's say let us say that, say suppose this is measured in time. Okay, this is measured in time, and say for example this is a mark which is say representing 2 seconds, right? And I have got a wave pattern, and the wave pattern is like this. Can we calculate the frequency of this wave? Okay, let's calculate the frequency of this wave. Frequency is 1 सेकंड में कितना साइकिल बनाता है. यहां तक कितना है, 2 सेकंड्स है. अब यहां से यहां एक साइकिल, फिर ये और ये एक साइकिल, 2 साइकिल, 2 cycles in 2 seconds. Therefore, in 1 second it will be making 1 cycle. So what is its frequency? 1 CPS. So its frequency will be 1 CPS, or it will be known as 1 hertz. ठीक है ना, 1 hertz. इसी को रखते हैं और आगे चलते हैं, and we talk about another parameter called time period, which we had discussed. Time period is something which is measuring time. Time period is measuring time. So time period is how much time you took to complete one cycle. How much time for one cycle. Acha children, looking at that example, can you tell me what is the time period? 1 second. In 2 seconds you did 2 cycles. एक साइकिल के लिए कितना टाइम लगता है? लेकिन आप लोग इसको आंसर करते वक्त एक चीज भूल गए, that frequency and time period are related by 1 upon t. If frequency was 1 CPS, then time period is 1s. है ना? देखो, दिमाग लगाना है हमेशा. एक साइकिल में कितना टाइम लगता है, हमने इसको जानबूझ के आपको यहां पे बनाया. अगर यही ग्रेड 8 का क्वेश्चन होता ना, तो मैं इसको यहां पे ऐसे बना, देखो क्वेश्चन इजी हो जाता है. दिस इज 1 सेकेंड. नाउ इफ आई आस्क यू what is the time period of this wave? Sir, in 1 second it is doing 1 cycle, frequency is 1 CPS, and for 1 cycle it took how much? 1 second. So the frequency, so the time period is 1 second. And if I change this axis now to something called x as displacement, then the distance traveled from here to here by the wave particles never travel, they remain at the same place. The disturbance travels. The disturbance traveled in 1 second, which is its time period, is the wavelength. When we are showing wavelength, then this axis should be in displacement. ये हमारा 1 wavelength हो गया. ठीक है? So time period t is equal to time for 1 cycle. Then we said something called the speed of the wave. Speed of wave. The speed of wave is denoted by a letter called c, which is equal to the frequency multiplied by the wavelength. And if you check, speed is always meters per second, frequency is per second multiplied by wavelength, which is meters. Therefore you land up in meters per second. ये भी clarity रखिए. Further, as I said, amplitude is a measure of the loudness of the sound. You should also know frequency is a measure of the pitch of the sound. The pitch, these are grade 8 topics, also known as the shrillness of the sound. A sound which has more frequency is said to be of higher pitch or higher shrill. Like a baby crying at night can be heard from a far off distance क्योंकि उसकी pitch बहुत high है. ठीक है, ये भी एक हमने देख लिया. और एक क्या चीज था? Frequency. Okay, now some more case-based type of questions. Let's see some case-based type of things. Okay, say suppose somebody is showing you two waveforms. The first waveform is in this manner, right? So this is one cycle, and the second waveform is in this manner. Wavelength is same, time is also same. The yellow one is a louder signal as compared to the pink one. The amplitude is more. The yellow one is a louder signal. समझ में आ रहा है? तो उसकी amplitude ज़्यादा है. और मान लो ये कोई boy रो रहा है और a boy is screaming. If the girl screams, it will be of the same loudness. If a girl screams, same loudness means this is same. The frequency is more. The number of cycles in that particular time is more. इसको हम कहते हैं more sound with a much more frequency. Did you study the last class? No. Did you study the last class? What do I understand by a phase? I have not studied. I can catch you by your eyes. A child has a right to question in my class whether you like it or not if you have read the previous class or you have understood. If I now see that people are not studying the previous class, I will no more be even obliged to put up the recording. If any child has been absent, they can ask the recording from me, bring a pen drive. But if the child has been present, I will not share that recording also, because I don't think in any of the most costly schools, and not that, I will be sharing the recording, creating groups within groups. I'm going to follow British policy. And the British policy is divide and rule. I will create group within group. Whatever people call me, I'm not worried. As I again say, you are coming here spending your parents' hard-earned money to study. You don't have the right to question me in class if you have not studied and come. Did you read your NCERT book? Did you read your Lakshmi Singh? Did you go through every notes? If you have gone through the notes, the way of reading is that this video gets played on your system and you open your rough copy and again you write. You didn't write. Did you write? No. No. I'll ask you here to come and draw 3 wave patterns and show me frequency, show me, explain me how, what is wavelength, what is frequency. So please don't disturb me in my class. Because you not studied is anyway at the back of my mind irritating me. After that, when you open your mouth, it irritates me more. And I don't call that as, what do you call, what? He is trying to be innovative. No, I'm a very old age teacher. That girl Aditi, if she stops me for a foolish question also, full marks. I will stop. That girl Bhavya stops me, full marks. I will stop. वो मेरे को आउटपुट देता है वो लोग. आप आउटपुट दीजिए, मैं आपके लिए रुकूंगा. Even इसके लिए, ये भी फुटबॉल खेलने गया था. He was not there. I'm very happy with his paper. I'm very happy. I'm saying. Clarity of maths is एकदम excellent. एक प्रॉब्लम नहीं कर पाया अलग बात है, but जो किया सॉलिड किया है. And don't mind that इसको इतना बात सुनाया करके. No, she's still one of the best. One of the best. I'm still saying. आप पढ़िए, फिर आप सवाल पूछिए, मैं आपको कुछ नहीं बोलूँगा. Is this fine? So we'll get some numericals also based on speed. Okay. Some more facts that we had discussed the other day, because we are not going in a linear manner on this chapter. We also spoke about something called the human audibility range. the human audibility range. The human audibility range is defined in terms of frequency. It's from 20 hertz to 20,000 hertz. 20,000 hertz. Any noise in this frequency will be able to hear it. If you are actually making a noise or a sound which is on this side, then this is known as infrasonic. Rhinos actually communicate with each other with infrasonic. This is the sonic range, and this is my ultrasonic range. Okay, this is ultrasonic. We can't hear them. And this again, we will see how ultrasounds are used. Okay, so go ahead now. So today we go ahead and start learning about, so again, a little bit about grade 8. Okay, let's go a little bit about grade 8. So the first thing comes sound. In order to create sound, I must be having a body or a system of particles in which there has to be vibration. ये तो आप grade 8 में पढ़ चुके हैं. One of the common examples are like if you have string instruments, then you can have membrane based instruments, then you can have air column based instruments, okay, air column based instruments, or even your voice cords for human being, right? All these things vibrate, and as a result of vibration they are making sound. Cycle ke bell ko, you start clinging the bell of the cycle and just put your hand on that particular metallic surface, you'll see there's a vibration, and as soon as you put your hand, the vibration dies, the sound goes away. So this is how sound is created, right? And from this way sound is created, I should also have a person who will be the recipient of sound, right? So from the creation of sound to the recipient of sound, I need something which will carry the sound wave along with it, and that is known as medium. I'm just revising grade 8. And this medium can be a solid, the medium can be a liquid, or the medium can be a gas. This is the more prevalent medium we use in the form of air. So as soon as a sound is created, the particles of air, we have got air particles, all grade 8 stuff, particles of air. So you set a vibration in them, right? And this vibration is nothing but, this is a disturbance, and this disturbance has to actually travel. This disturbance has to travel and reach your ear. My relative who is based out in Delhi might try to call me in Hyderabad today, but I am not hearing her. That does not mean that she is not able to vibrate. She is vibrating, but the vibrations die down by the time they're reaching Telangana. So we have to create some alternate way. So what do? We create electrical signals, convert them into electromagnetic waves so that they can travel much more faster, right? So the vibration has to travel. In other ways, the disturbance has to travel. And remember, since this disturbance is traveling, this disturbance will travel in the form of a wave. It will go in the form of a wave. Clear? In this wave, again, we will have particles. And we studied that in wave, the disturbance travels, particles remain at the same position. So let's understand like a small domino effect of having a lot of toddler kids, all seated compactly in a metro train. And you start tickling the first child. By that moment, you'll see this child is also laughing and giggling, and he is also, or she is also vibrating, because the disturbance has traveled. But the particles are not traveling, the disturbance is traveling. Same thing happens in a wave. So we will today understand how does this go actually from this to the other place. So this brings one more conclusion to us, that if I don't have a medium, I can't actually hear sound. That was your grade 8 question, if you remember. How do astronauts communicate with one another? So they communicate with one another using radio sets. Best example for that would be what? A best example for that would be, I don't know whether you have done these naughty things we used to do, like mom gives you some Bonvita or something, steel ke glass mein hote the. After that, we used to be fascinated by Ramayana. So we used to think we'll enact like Hanuman. So take the glass and suck the glass inside such that the glass is held on your lips. At that time, you try to speak. Nobody will hear. Nothing is heard because you have already created vacuum by sucking out all the air inside. So very simple example, sound needs a medium to travel, whereas light, we will see, does not need any medium to travel. From the sun to the earth, there is an atmosphere, then there is a space where there is no medium at all, but still light is traveling. However, sound cannot travel. So sound needs a medium to travel. And obviously, the speeds will be different. In solid, sound will travel fastest. Like in iron, sound travels at the speed of around 5,000 meters per second. Liquid, it will be less. And in air, it is the least. Round about something like 343, I might not be correct, okay? Roughly, approximately 343 meters per second is the speed of sound in air. And this also depends on temperature. This depends on temperature. अब आप common sense लगाओ, आपको answer आ जाएगा. Who is carrying the sound from me to you? Air particles. And what is needed in these air particles? जरा air particles को भी देखते हैं. Okay, let's see the air particle. Let me make my air particle very big. This is an air particle, something like a sofa cushion, the side cushion, the booster cushions which we have, chota wala. This air particle should have one property, which it should have a lot of elasticity in it. इसको आप गुदगुदी दे रहे हो ना, तो ये क्या होना चाहिए? ये shrink भी करना चाहिए और ये expand भी करना चाहिए. दोनों properties इसके अंदर होना चाहिए. That will actually give rise to compression and rarefaction, which you will see. That when you compress it, it's like compressing a cushion, but it won't stay like that. It will again open up. But as it opens up, it compresses the cushion near it. All these cushions are stacked one. These are all air particles. If this fellow gets compressed, then this fellow says, "Chalo, थोड़ा जगह मिला बैठने के लिए." ये expand करेगा. At that time instant, as soon as it compresses, because it is elastic, मैं compress क्यों हुआ? मुझे तो फैलना चाहिए. ये जैसे ही फैलेगा, ये फिर compress हो जाएगा. So whenever we draw wave, this is at one instance of time. In the next instance of time, the crest will not be here. The crest will be here. The trough will be here. Imagine Mexican wave in a stadium. The same person is climbing, standing up and getting down. So it's not that every time. This was a picture taken at a time t. In the immediate next time, this will be on a trough, this will be on a crest, this will be on a trough, this will be on a crest. इसीलिए तो आपको वो गिली मौत टक 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 करना दिखाई देता है. And the water is, it appears as if the water is coming till your leg. ठीक है? Understood? So we will today, these are some grade stuff. Anything that we left out, okay, it needs a medium unless you have a medium. And look at this. In air, the sound travels at the least speed. Then also we feel, मैंने बात किया और आपने सुन लिया. कोई delay नहीं है. But you put your head on that table and let me just take my nail and scratch the table here. Unbearable हो जाएगा आपको because the sound is traveling much more faster. Are we fine till here? Now let's say it depends on temperature. Now see, ultimately who is carrying the sound? Vibrating air molecules are taken or air particles. The vibration is dependent upon the amount of kinetic energy they have. More is the temperature, more is the kinetic energy. Therefore, on a warmer night, sound will travel much more faster than on a colder night. क्योंकि उस दिन हरकत बहुत ज्यादा है. Have you understood? So let's now go to grade 9 stuff and get into the topic again on wave and see classification of wave. Waves, the wave classification. This is basics of grade 12 again. Sorry, grade 11, wave classification. Now we are studying wave. You are not limiting yourself to sound. Vibratory motion, oscillatory motion, alternating current, light, सिंपल हार्मोनिक मोशन, साउंड, सब चैप्टर के लिए ये वेव है. ये एक ही प्रॉपर्टी दिखाएगा. ठीक है? इट्स नथिंग रिलेटेड टू साउंड. साउंड को समझाने के लिए हम वेव दिखाते हैं. व्हाई? बिकॉज साउंड हैपेंस थ्रू वाइब्रेशन. अ वाइब्रेशन, ओके, लिटिल बिट मोर. लेट्स सी लाइक दिस. डू यू नो द कांसेप्ट ऑफ पीरियोडिक मोशन? लेट्स कॉल व्हाट इज पीरियोडिक मोशन. अ मोशन दैट रिपीट्स इटसेल्फ आफ्टर रेगुलर इंटरवल्स. The moon goes around the earth goes around the sun every 365 1/4 day. That's a periodic motion. After that, जैसे हम एक फैन को घुमा रहे हैं और से इट्स अ मेरी गो राउंड एंड आर्यश को बिठा दिया. आर्यश मॉम इज हियर ऑन दिस साइड. हर 2 सेकंड के बाद बच्चा मेरे सामने, 2 सेकंड के बाद बच्चा मेरे सामने, 2 सेकंड के बाद बच्चा मेरे सामने. दैट मीन्स रोटेटरी मोशन इज पीरियोडिक मोशन. ठीक है? मेड को लगा दिया बच्चा घुमाने. हाँ क्या कर रही हो? हाँ ट्वीं. So you know, अभी देखो बच्चा को ले लो गोद में and if she is busy talking, still she will do because she has understood that at this interval the बच्चा comes this side. समझ में आया? That is periodic motion. Another very weird example of periodic motion. Now I realize, like when I was in my childhood and I used to sleep beside my mother, I used to have a lot of fascination of narrating stories, but stories are such that stories never end. फिर पता है क्या हुआ? फिर पता है क्या हुआ? To show that my mother is very much listening to me, what she used to do, तो मैं वो में समझता था, she's paying great attention, but that is actually a periodic motion. बाद में मैं one day what I did, I stopped my story, I used to see my mother, तो ये periodic motion है. अब इसमें क्या लेके आते हैं, कुछ कुछ मोशंस को आइडेंटिफाई करते हैं. रोटेटरी मोशन हो गया, से वाइब्रेटरी मोशन. Vibratory motion. Also, you know one more name of this, which is known as oscillatory motion, pendulum wala motion. Is it a periodic motion? Yes, I know. Every 1 second it is going to come. It's a periodic motion. Rotational is different. Oscillatory is different. Oscillatory when you oscillate across a mean position. Hacksaw blade से आप काट रहे हैं, periodic motion. You can predict it. ऑसिलेटरी का एक और क्लास होता है, आगे चल के आप पढ़ेंगे, SHM, सिंपल हार्मोनिक मोशन. दैट इज ऑल्सो पीरियोडिक मोशन. आवर साउंड इज क्रिएटेड बाय वाइब्रेशन. देयरफॉर any periodic motion can be represented by wave, so sound can also be represented by wave. यहां से आ जाता है वो स्टोरी. Classification on the basis of medium. On the basis of medium, this is the first basis, classification basis. So on the basis of medium, you can classify in two ways. Needs medium, does not need medium. Needs medium, does not need medium. If you need a medium, then you are known as a mechanical wave. Mechanical wave. अरे कैसा गाड़ी है? Mechanical है, मतलब ऑटोमेटिक नहीं है वो. एज सिंपल एज दैट. मैकेनिकल वेव, धक्का वक्का खा के जाएगा. ओके, कैन यू टेल मी व्हाट आर लाइक वाटर रिपल्स? मैकेनिकल वेव. साउंड इज आल्सो अ मैकेनिकल वेव बिकॉज साउंड नीड्स अ मीडियम. हम हवा काट देंगे तो साउंड नहीं सुनाई देगा. सो साउंड, if you want to classify sound as a wave on the basis of medium, then sound falls under mechanical waves. Slinky. Slinky जानते हैं आप? Slinky is take a spring like this, a coil spring. This is called a slinky. इस slinky से आप टिक 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 कर रहे हैं, तो you need a medium through which it is going. It's a mechanical wave. Mechanical waves are the waves which actually will need a medium. Waves which do not need a medium are non-mechanical waves, and one of the example of this are electromagnetic waves. Example, light. ये कुछ भी नहीं चाहिए. And whatever is in light, gamma rays, है ना, X rays, then UV, IV, micro, radio, all these do not need any medium. कहीं से भी कहीं जा सकता है. Clear? They are called electromagnetic waves. Is this classification understood? Mechanical waves and this. What is more important is the other type of classification. Now, for every wave to happen, what does a wave show? A wave shows the schematic representation of a vibrating body and the disturbance created by it. In wave, we show how is the disturbance propagating. याद रखिए, particle कभी भी नहीं जाता है फुटबॉल में, सिर्फ wave जाता है. आदमी स्टेडियम में उसी जगह उठा बैठा करता रहता है, तो particle remains at the same place. Only the wave propagates. So, on the basis of direction of vibration of vibrating body with respect to direction of propagation of wave. बहुत बड़ा कुछ लिख दिया, ऐसे कोई बात नहीं है, इजी है समझना. यहां पे आप कैसे कंपेयर कर रहे हो बेटा? हाउ आर यू कंपेयरिंग? हाउ इज द वेव गोइंग and how is the particle vibrating as compared to the direction of the wave? Have you understood? Clear? Now let's take our slinky wala example. Let's take the slinky wala example. Or let's take the wave, the rope. जिम में जो rope होता है ना हमारे पास, So you are exercising with the gym rope, and let's say the gym rope is creating a wave like this, and we are finding that the wave is traveling in this side and our user is on this side. वो ऐसे exercise कर रहा है, wave ऐसे जा रहा है. And on this gym rope we have tied one small red satin ribbon को tie कर दिया है. ठीक है, तो आइए इसमें देखने की कोशिश करते हैं. अगर आप वेव के प्रोपोगेशन को देखेंगे, if you try to see the propagation of wave, the wave is propagating in this direction. Do you agree? And if you see the direction of vibration of this ribbon that we have put, the direction of vibration of the ribbon, then the ribbon is actually vibrating up and down in this direction. Have you understood? Where the particle, we are supposed to see the particle's vibration as compared to the wave's propagation. Now, in this case, we find that the particle is actually vibrating. The particle is actually vibrating at 90 degree to the direction of wave. Such a wave will be known as transverse wave. Such a wave is known as transverse wave. If the particles of the wave vibrate at 90 degree to the direction of wave, जैसे मान लो आपके गाड़ी के डैशबोर्ड में आपने क्या लगा दिया है, एक स्प्रिंग लगा दिया है, मिकी टक 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 कर रहा है. Now what is the direction of Mickey's vibration? On the y axis, up and down, up and down. वहीं जैसे मिकी अप एंड डाउन कर रहा है ना, मिकी के हाथ में एक पेन दे दीजिए और एक किचन टिश्यू रोल को खींचते जाइए. You will see the wave is getting created. wave ऐसे लंबा आएगा और मिकी लेकिन अप एंड डाउन जा रहा है, ट्रांसवर्स वेव क्रिएट हो रहा है. Are you understanding? Suppose ये मिकी का हाथ है, मिकी अप डाउन कर रहा है और आप यहां से एक किचन टिश्यू रोल खोलते जाइए. So how will the, have you seen an ECG report? How does the ECG plot? Does the plotter move? No, the paper moves. The paper moves, the plotter does not move. Plotter is always doing this. और यहां से आप पेपर खींचते जाइए तो कैसा आएगा, वेव नहीं आ जाएगा? बिल्कुल. So that is known as a transverse wave. Now here is where children get confused. कहां confuse होते हैं? अब देखो, electromagnetic wave is also an example of transverse wave. I called it electromagnetic wave because in the previous one I was actually checking the wave on the basis of does it need a medium or not. अच्छा मीडियम तो दे दिया भाई साहब, मीडियम नहीं चाहिए, पर इसमें भी तो कुछ वाइब्रेशन हो रहा है. In electromagnetic waves, electromagnetic, you have an electrical wave and you have a magnetic wave. The electrical wave will be vibrating on the x-axis. The magnetic wave will be vibrating on the y-axis. Just imagine. Combination of these two gives another wave, which is the electromagnetic wave, which will be vibrating on the x-axis. ऐसे जाएगा. One wave on x-axis, one wave on y-axis, and the combination wave proceeds on the z-axis.
The disturbance is happening without disturbing it.
Which one? No, in electromagnetic case, you will read there is a simultaneous disturbance in the magnetic field. Every time you cheer a magnetic field, an electric field is created. Very nice question. What she's trying to ask is, अगर मीडियम ही नहीं है तो किसको डिस्टर्ब करके जा रहा है? वेव इज अ डिस्टर्बेंस ना, वो खुद एक दूसरे को डिस्टर्ब कर रहा है. Rather, I should ask you, how is the electromagnetic wave sustaining itself? Somebody speaking from England and you are hearing here on radio, इतना दूर आ कैसे रहा है? Once you create a electrical wave along with a mechanical, ये ही दूसरे को मारेगा, वो उसको मारेगा. Every disturbance in electrical creates a mechanical. So a electrical disturbance, mechanical created. Mechanical created means another electrical will be created. Another electrical, another mechanical. So that waves diagram actually comes very stylish. One will be on this axis. एक wave ऐसा रहेगा, Z axis. एक x axis में रहेगा और totally वो y axis में travel करेगा. अब 3D diagram होने से is better to explain. You can just Google electromagnetic wave on just Google image. You can understand. They'll show you a 3D. So the first form of wave on the basis, if the particles are vibrating in 90 degree to the direction of wave, I call it a transverse wave. Okay. Now there can be another type of wave. Now just see. I'll make another wave. Just try to see this. Now I have the slinky, right? A slinky is like a chuda. Now take the slinky, take the slinky spring and don't shake it in this manner. Pull it and release it, pull it and release it. You will see zones of compression, zones of rarefaction. Zones of compression, zone, a shrink is a very nice example. इससे आप ट्रांसवर्स वेव भी बना सकते हैं, लॉन्गिट्यूडनल भी बना सकते हैं. इसी स्लिंकी को ऐसे ऐसे कीजिए, you will get a transverse wave. So this sort of wave, if you see, this is what we call as a zone of, this is a compression zone, and then you get a rarefaction zone, again a compression zone, again a rarefaction. If you try to identify one particular particle out here, this particle out here, ये पार्टिकल कभी इस साइड जाता है, कभी इस साइड जाता है. वेव किस साइड जा रहा है बेटा? The wave is traveling in this direction. The wave is traveling in this direction. How is the particle vibrating? If the particles of wave vibrate in a direction to and fro along the same direction of propagation of wave, to and fro along the same axis of propagation of wave, then such waves are known as longitudinal waves. लॉन्गिट्यूडनल वेव्स कैसे जाता है? ऐसे 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 जा रहा है. साउंड इज द लॉन्गिट्यूडनल वेव because you go to my previous example, where were the kilos? This, if you see these kilos, this kilo ऐसा करते रहेगा, ऐसे गिगलिंग करते रहेगा सब. आपको नहीं लगता इसको गुदगुदी करने से सब ऐसे 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 करते रहेंगे? So you are actually propagating the disturbance this side. Each particle is vibrating to and fro about the direction, same direction, not at 90 degree. Such a case we will call this wave as longitudinal wave, and sound is an example of longitudinal wave. So let's have a quick recap. Is sound a mechanical wave? Yes. Why? It needs a medium. क्या हो गया? Is sound a longitudinal wave? Yes, because in sound the particles of the medium vibrate in a direction along the direction of propagation. ऐसे ऐसे जाता है. Is light a transverse wave? Yes. Okay. Then next question comes, water waves. Let's say water waves. Let's answer that. Water wave is a transverse wave, but is a mechanical wave. Water wave कैसे आता है? ऐसे ऐसे आ रहा है. दूर में जो डक है, the swan, वो डक आपको कैसा दिखता है? ऊपर जा रहा है, नीचे जा रहा है, ऊपर जा रहा है, नीचे जा रहा है. और वेव कैसे आ रहा है? आपके बिल्कुल पाँव में वेव आता है ना, आप इंस्टा रील बनाते हो पाँव में. Wave is coming on this direction, particles are vibrating up and down. So that is a transverse wave. And a medium is needed. पानी के ऊपर ही वो हो रहा है. So it's a mechanical transverse. Sound is a mechanical longitudinal. Clear? तो आइए अब देखते हैं that suppose we have the source, you have a source and you have the recipient. So from the source you should have in between something which is known as medium, and for the simplicity we are taking the medium as air, and sound is traveling. So this is the sound. ये जो sound है और यहाँ पे recipient का ear है, ठीक है ना? This is the medium. The medium is air. So far we have understood what is sound. Sound is a mechanical wave. Why? Because sound needs a medium, and sound is a longitudinal wave. Why longitudinal wave? Because the particles of air vibrate to and fro along the direction of propagation. अब क्या होता है? जैसे मैं यहाँ पे बोलता hello, so immediately as a person speaks, he compresses the air in front of him. See, to show it in drawing, थोड़ा ऐसे दिखाते हैं आपको. Okay. Okay. Say suppose somebody has spoken, a word has been hello बोला. Hello बोलते ही first he does what? Imagine this to be a sofa cushion. वो इसको compress कर देता है. So we will get a zone of compression का एक zone आ जाएगा. This is a zone of compression. Now children, whatever I am drawing is at a particular instance of time. उस वक्त, this is suppose at 8:10:35, उस वक्त जैसे ये compress हो गया, बाजू वाला feels बैठने का कितना जगह मिला. बाजू वाला फैलेगा. एंड यू कैन अंडरस्टैंड बाजू वाला साइड दोनों को खिसका देता है, तो यहाँ पे फिर एक कंप्रेशन आएगा आपको, एंड यू विल गेट अनदर रेयरफैक्शन हियर. This was at say HH, MM, SS. So many hours, so many minutes, and so many seconds. Immediately, the next interval, what will you find? The next interval, once they get compressed, they will say, हम क्यों पीसेंगे? हम उन्हें पीसेंगे. हम क्यों पीसेंगे? हम तो उन्हें पीसेंगे. Immediately on the next part, you will find that they have become, जैसे ही उनको आपने कुशन को दबाया ना, कुशन एक्सपांड कर गया, and rarefaction will be created here. I hope you have understood now. As long as this disturbance can travel to the distance where your ear is, you will be able to hear. So what do we call it? We call this zone as rarefaction, compression. Then again rarefaction, compression. Then again compression, rarefaction. Rarefaction, compression. इसको हम बोलते हैं rarefaction and compression. So if you now look at the sound wave is a series of rarefaction and compression traveling along the direction. चपक 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 ऐसा करके जा रहा है. जितना दूर तक जा सकता है उतना दूर तक सुनाई देगा. अब आप बोलोगे सर साउंड को तो आपने एक वेव बोला था, मैं तो अब भी वेव ही बोलता हूं बेटा. सर इसको वेव के माध्यम में दिखाइए. तो वेव में हम कैसे दिखाते हैं? अगर हमारा कंप्रेशन ट्रफ है तो रेयरफैक्शन क्रेस्ट होगा. अगर ये ट्रफ है, यहां भी आप वेव दिखा सकते हैं. अंडरस्टूड? सो अ साउंड इज a mechanical wave, a longitudinal wave, and in other words we also say a sound is a pressure wave. क्योंकि जब तक आप प्रेशर क्रिएट नहीं करेंगे किस पे, एयर पार्टिकल्स पे, मीडियम पे, साउंड वेव जाएगा ही नहीं. नाउ यू शुड आस्क सर हाउ आर दीज क्रिएटेड? एवरी ब्लॉक इज लाइक ए कुशन ऑफ सोफा. अगर तुम उसे दबाते हो, वो मैं क्यों दबा, ऐसे ऐसे खुल गया, तो साइड वाला दब गया ना, मैं क्यों दबूंगा, मैं खुलूंगा. तो ये एक बार पिसता है, एक बार अमीर गरीब अमीर गरीब अमीर गरीब, और ये डिस्टर्बेंस ट्रैवल करता है. इसको हम कहते हैं हाउ साउंड ट्रैवल्स फ्रॉम वन प्लेस. क्लियर? नो इश्यूज? ठीक है. तो देख लेते हैं और कोई टॉपिक आपका छूटा है क्या. No, speed of sound, you know that. The speed of sound is maximum where? In solids. That's the reason when a train is coming and you put your ears on the track, you hear the train sound much more clearer and much more. You hear the sound much more faster. Achha, sound speed is very less. This again grade 8 question. Why do you see the thunder first and the thunder you hear, the lightning is seen first and the thunder is heard later? Because the speed of light is much more. ठीक है ना? And ठीक है. So there are some. Let's do one problem based on the numericals that we had. So a question is out here. We have a sound wave. So there's a sound wave, and the wave has a frequency. So the frequency is given to me. The frequency is equal to f, which is equal to 2 kilohertz. K is z. Kilohertz means 2 into 10 to the power 3 hertz. Okay, and it has a wavelength. बच्चा सवाल है ये सब. It has a wavelength, and the wavelength is lambda. Wavelength is given as 35 centimeters. 35 centimeters, which means 35 into 10 to the power minus 2 meters. Always make them in SI unit. It says how long will it take to travel? So the distance is 1.5 kilometers. और इसको ट्रैवल करने के लिए इस वेव को कितना टाइम लगेगा? वेरी नाइस क्वेश्चन. इट्स लाइक अ साउंड सिग्नल. 2 किलोहर्ट्ज मींस दिस आर वेरी लो फ्रीक्वेंसी साउंड, बेस के जैसा है. You know the difference between in if you handle your car stereo, you will देखो अनन्या छोड़ दो उसको, वो मैं भी जानता हूँ कैसे करते हैं. CBSE is all about now content and competency based. There are many ways where grade 10 students हैं वो ये वाला mentality रखते हैं ना, simple question answer नहीं कर पाते हैं. But it's not that they don't know. They know. And if you give them a simple example, like yesterday, you'll not understand parallel networks and all. They said if one bulb gets fused, what happens to the other two? बच्चे बोलने शुरू कर सर उसमें ग्लो बढ़ जाएगा. आपके बेडरूम का बल्ब फ्यूज हो जाने से ड्राइंग रूम में ग्लो बढ़ जाता है क्या? That thought process, you are not able to connect with the question. That's why you are miserably failing in that question. क्योंकि आप इसको मजा नहीं ले रहे हो इसका. ऑडियो सिस्टम्स में हमारे पास दो बटन्स होते हैं, जिसको एक होता है बास लिखा रहता है, बेस, और एक होता है ट्रेबल. ट्रेबल मींस यू आर इंक्रीजिंग द फ्रीक्वेंसी, ये सब साउंड आएगा. बेस बढ़ाओगे तो वो सब साउंड बढ़ेगा. ये लो फ्रीक्वेंसी है, ये बेस साउंड है. इसको हमें ट्रैवल करवाना है कहां तक? 1.5 किलोमीटर्स. तो सबसे पहले यहां वही वाला फॉर्मूला यूज हो जाता है, दैट डिस्टेंस इज ऑलवेज इक्वल टू स्पीड मल्टीप्लाइड बाय टाइम. हमें टाइम पूछा है, हमारे पास डिस्टेंस दिया हुआ है, उसके लिए हमें स्पीड चाहिए. एंड स्पीड इन द चैप्टर ऑफ वेव इज अ प्रोडक्ट ऑफ फ्रीक्वेंसी एंड वेवलेंथ. I will not do this problem after this. That you are supposed to do. And while using distance, please ensure that this is 1.5 into 10 to the power 3 meters. तो आपका टाइम का आंसर किस में आएगा? ऑटोमेटिकली सेकंड्स में. let us see now. See the beauty. ऐसा मत करो, मैथमेटिक्स का मजा लो, देखते हैं आता है कि नहीं. ठीक है, हमें क्या निकालना है बेटा? टाइम. टाइम इज इक्वल टू डिस्टेंस अपॉन speed, right? Distance is distance and speed is what? Frequency multiplied by wavelength. Check करते हैं. Distance मीटर में है, frequency something by second में है, और frequency lambda किस में है? मीटर्स में है. मीटर ने मीटर को काटा, so ultimately is 1 upon second, which is equal to second. Our equation is correct. When you go to higher classes and you do physics, you have to develop your equation. How will you understand whether your equation is correct or not? Unit testing करके देखिए whether the equation is correct or our equation is correct. Now the mistake you might do is calculation mistake. ये एंगल से प्रॉब्लम को अटैक कीजिए. ये रट्टू तोते की तरह मत कीजिए. देखो करेक्ट है ना, प्रूफ कर दिए हैं. बाकी आप करो, मुझे मतलब नहीं है इससे. आई थिंक यू हार्डली हैव anything more than grade 6 level mathematics out here, just numbers, some unless and only goof up on these. Clear? Understood this? Okay. So sound is also a type of energy. And एक और चीज जान के रखिए, sound is a form of energy. Sound is a form of energy, and this energy passing per second per unit area is called the intensity of sound. यार बहुत इंटेंसिटी का साउंड आया था. सोचो, बहुत इंटेंसिटी का साउंड आया था. एक एग्जांपल लेते हैं. कौन सा इंटेंसिटी साउंड हुआ था? फाइटर जेट टेक ऑफ किया. इज इट ए हाई इंटेंसिटी साउंड? यस. नाउ ट्राई टू मैप दिस पर सेकेंड. एक सेकेंड वाव ऐसा साउंड किया आपके सामने. पर यूनिट एरिया, इतना बड़ा एरिया में. आई डोंट नो हाउ मेनी ऑफ यू पीपल हैव द एक्सपीरियंस ऑफ गेटिंग डाउन एट पुणे एयरपोर्ट. पुणे एयरपोर्ट इज अ combined airport for Pune Air Force, Indian Air Force and civil, and that's the only airport. Now they allow buses, but the bus doesn't take you anywhere. You will walk to the airport, and as you will be standing, your goosebumps aa jayega. Is Sukhoi's base. Every 2-3 minutes Sukhoi's will, you'll see the jet blast and they'll take off. अब कान एकदम फट जाएगा आपका. jet blast जिसको बोलते हैं. So intensity is per second per unit area. अगर आप ज्यादा एनर्जी, ह्यूज एनर्जी ना, in that energy we could have done anything. So that sound is called high intensity. And then there will be some people classroom में बात नहीं करते, छोटे छोटे. What is your name?
My name is. टाइम भी ज्यादा ले रहा हूँ, बड़े एरिया में सुनाई भी नहीं देता है.
तो इंटेंसिटी कम है, खत्म. एक एग्जांपल हो गया. फायर ब्रिगेड गुजरता है, जिसको हम लोग डॉपलर इफेक्ट बोलते हैं. फायर ब्रिगेड. Does a fire brigade come with it? This another thing you'll study in higher classes called Doppler effect, where you feel that a wailing noise is coming. Noise is not wailing. Ambulance उसी intensity से अपना siren बजा रहा है, लेकिन आपको क्या लगता है? आपको पार करके गया. You feel that as the source comes near you and goes away, एम्बुलेंस की आवाज कम हो गई है. एम्बुलेंस लेकिन उसी आवाज से जा रहा है. But you can make it. That's called Doppler effect. तो Doppler effect हम हायर क्लासेस में पढ़ेंगे. तो इस चीज को हम कहते हैं intensity of sound or loudness. You have heard speed of loud in different media, and then comes sound is a wave. So every wave follows laws of reflection. Like light is a wave. Light में अगर law of reflection है तो sound में भी law of reflection होगा. So somebody might ask you, if a sound wave is incident at 30 degree, at what degree should it be reflected? 30 degree. Laws of reflection hold for waves. You were a kiddo, so you studied it only for light. Light is also a wave. ठीक है. अब एक एको का कॉन्सेप्ट समझ लेते हैं. आज उतना टाइम है हमारे पास. एको तो आपने सुना ही होगा. कहाँ 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 जा रहे हो, जा रहे हो. ओके, एको. In this we will have a source, and the source will emit a sound. This sound has to travel and strike some obstruction, and then has to come back. Then has to come back and again hit the source. So the source will actually hear the sound once when it is emitted, and second time when the reflection comes. This is called the echo of this. However, there is a catch out here. We as human beings, our ears can distinguish in an echo, that is distinguish between two sounds if they have an interval of 0.1 second spacing between them. एक ही टाइम पे दो आवाज, एक ही आवाज एक साथ छोड़ोगे तो उसको दो आवाज नहीं पकड़ता है. कितना इंटरवल होना चाहिए? 0.1 सेकेंड इंटरवल होना चाहिए. ओके, सो 0.1 सेकेंड इंटरवल में अगर दो आवाज मेरे पास आएगी, माई ईयर हियर्स इट एज टू साउंड्स. और एको तो वही है ना, ढिचक्याओ दो बार आएगा आपका. ठीक है. नाउ सी, ये सारा कमाल हो रहा है एयर पे. ठीक है, वही वाला फंडा लगाते हैं, लोग रटते हैं. आ जाओ. डिस्टेंस इज इक्वल टू स्पीड इनटू टाइम. अच्छा सर, हम हमेशा एको सुनते हैं क्या? देयर हैज टू बी अ कंडीशन. आज इस रूम में हम एको नहीं सुन रहे हैं. देयर इज नो एको इन दिस रूम. क्यों नहीं सुन रहे हैं? दो रीजन हो सकता है. Either we are not getting the reflection sound. Why you are not getting? That will come out from this calculation. Now let's take the time as 0.1 seconds. This is the minimum time. इससे ज्यादा होने से भी आपको लगेगा. This is the minimum time. Are you getting it? This is the minimum time. अच्छा, all of you on that, huh? There is this Teams and all. I can't help anything. Microsoft is having some policy revisions. If you are mapped to team and you suddenly find very good, यही सब आते रहेगा, that you have got mapped. Communities can be logged in only by adult account or parent verified account. Maybe the time when you opened your account, a group दिखेगा. हाँ. So who understands it gets the solution. There's a girl, इसी के स्कूल का है, Aditi. Her name is also Aditi, but she's of Bhavya school. Okay, so you need to just do one thing. If your अकाउंट इज नॉट पेरेंट वेरीफाइड, मतलब आप बच्चा अकाउंट रहेगा तो नहीं होगा, या तो नया अकाउंट एक खोलिए. एंड प्रेफरेबली हैव टू अकाउंट्स इन योर लाइफ. वन शुड बी ऑन outlook.com. दैट इज अ माइक्रोसॉफ्ट पोर्टल. इट गिव्स यू अक्रॉस माइक्रोसॉफ्ट, वेरी गुड. एंड वन Gmail account. When you are creating that and you are entering on Teams, make sure you are parent verified. That girl did it and just sent me the email. I just sent the link invite on email. I'm rather not link invite. I just, since she has mapped it on Microsoft Teams, you just include her name, it will immediately show Aditi Nambiar. It shows her name and she is immediately able to. नहीं तो ये ऐसे मैसेज आते रहेगा, I am unable to. I don't create Microsoft Teams. मैं थोड़ी Microsoft Teams खोलता हूँ. Why are you able to see? Mine is an adult account. तो आप छूटे हो ना, आप सबसे पहले अपना अकाउंट चेक कीजिए. That account will need parent verification. ये नया हुआ है and it is happening across. Like in my wife's school, बच्चे सब हो रहा है. ये आपका भी हो सकता है. All of you might have been kicked out of. You can see groups chats but not community. I don't know what they mean. Community restriction is only to adult accounts, so check that. हाँ, आप क्या करो, एक नया अकाउंट क्रिएट करो. हाँ, वो होएगा. अपना नाम थोड़ा स्टाइलिश कर दो. हाँ, नॉट द सेम नंबर, अलग एक नंबर लो, गर्लफ्रेंड का नंबर डाल दो उसमें, बस हो जाएगा. डाल दो अत्रेया डैश मुखर्जी. हाँ, हो गया. तो कहाँ पे था ये? हाँ, चलो ये साउंड. तो we can hear an echo, only there is a time difference of 0.1 seconds, right? So what is the speed of sound in air? The speed of sound is 344. What has happened? Okay, the speed of sound is 344 meters per second. This is what? This is meters per second. Okay, well, they are also saying stop the class. 1 minute. Slow, guys. Some booting is going on. Suddenly becomes slow. So this is 344 meters per second multiplied by. If you multiply this, what will you get the value as? 34.4. So this value comes how much? 34.4 meters. Is it clear? 34.4 meters your sound wave should travel to reach you. मतलब यहां से यहां जाके यहां आने में कितना डिस्टेंस होना चाहिए? 34.4. That means the blockage should be at what point? 17.2. 17.2 is the minimum distance for an obstruction to be for you to hear an echo. इसलिए ये सब 17.2 में नहीं है. अब आप बोलोगे सर जब मैं बेसमेंट में जाता हूं ना तो बहुत 17.2 से भी तो दूर गाड़ी है, एको आ रहा है, एको एब्जॉर्ब हो जाता है आपके पास आने से पहले. Have you ever checked into a house which is a new flat? At that time you say यहाँ हमारा बेडरूम होगा, वहां सोफा रखेंगे, यहाँ फ्रिज रहेगा. उसी घर में कर्टेन्स लग जाते हैं, सोफा लग जाते हैं. There is no echo. उसको रेवर्वेशन बोलते हैं. आगे पढ़ेंगे उसको. एको, मल्टीपल एकोज आर नोन एज रेवर्वेशन. इसलिए कॉन्सर्ट हॉल्स में तो और भी ज्यादा होना चाहिए. कोई गिटार टंग खिंचा टंग डंग 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 10 बार करेगा. So a lot of soundproofing is required because too much of reverberation is not good. That is also echo, but multiple echoes. So this is a concept which you should know. An echo can be created only if the obstacle is at a distance of 17.2 meters minimum. Sir, how did you get that 17.2? Understand the logic and then we'll close the class. In order for the human ear to distinguish between two sounds, they should have an interval of how much? 0.1 seconds. Speed of sound is 344. मतलब 0.1 की देरी से आना पड़ेगा. तो इतना देर क्रिएट कर लो. इतना टाइम को 344 से मल्टीप्लाई करेंगे तो डिस्टेंस कितना आता है? 34.4. तो जाने का 17.2 और लौटने का 17.2. That means the obstruction should be at a distance of 17.2 minimum from the source in order for you to hear a distinct echo. अगले क्लास में reverberation पढ़ाएंगे, uses of sound and ultrasound, and the chapter will end. ठीक है? Thank you. And check your teams. And you know I've told you teams में गड़बड़ी क्या है.